Invensys is basically a wholly owned subsidiary of Tesla Technologies. In general, Tesla is in the IP license business. So we develop new technologies that other companies can use either for more advanced packaging or digital imaging optics, or just interconnects like the division I was in, microelectronics. And Invensys simulation, I think it's very critical there because as an IP company, we can't really afford to make mistakes. You best have to do it right the first time. So what else can you use to achieve that goal? Electronics, microelectronics, we got into the game much later. And so there's still that old school thinking about design it, build it, and test it, and see what happens next. But I think that mentality is changing. So as the goal of my group, we want to do simulations upfront to optimize the solutions, and so that we can get the best design or the optimized design from the get-go. I was an Ansys Classic user for many years, for over 10 years. So then I went to Tesla where they use Abacus. However, it doesn't have the flexibility to do optimization and parameterizations. So let's say, to give you an example, if I have a created assembly and I just want to do some quick what-if designs by changing a few parameters, let's say the diameter or the height, you can't do that. It doesn't have that parametric capability. So you have to redo the model from scratch, which is definitely not acceptable. So I did a thorough study of the two packages, both the thermal side, mechanical side, electrical migration side, and I did a side-by-side comparison and made a case to the management. And they say, all right, that's very obvious. We need to go with Ansys because Ansys does provide that capability to change the model on the fly. I think now we use Ansys in almost everything we do in the mechanical, the engineering side. We have different people creating the model first. We use SolidWorks to create the model. Then I will get the model because there is the interface, direct interface between Workbench and SolidWorks. So I can get the model from there, and then do model slicing, boundary condition assignment, meshing creation, and run the analysis from there. We use Ansys to create the model based on the concept and see if it's even feasible based on certain criteria, depending on what the device we are thinking about. So then we'll see whether it will fly at all. If it doesn't, we will rethink our patterns and then redo it. So that possibly will save us a lot of money. Just imagine if we had to do this in real time with real parts, and how much that will cost. Traditionally, Tesla slash Invensys has been focusing on the package level, but increasingly we see the possible pitfalls of that approach because nobody really wants to just buy one piece of the technology and try to make it work in a system setting. There's no way we can test it out with a real system. We just don't have that. But virtual world does give you that option. Basically, that's what simulation can bring to us. We can simulate how the component or package works in a system environment without getting a real system, which would be too costly and next to impossible. I really like the way Ansys is going in the multi-physics domain because nothing is isolated in the world. So everything is interdependent on something else.